we're going to talk about types of lines and types of angles. There's a lot of notes today, so let's get ready to do some work. Okay? The kind of lines that we're going to be talking about today, guys, is we're going to be talking about parallel lines, perpendicular lines, and intersecting lines. So first, let's talk about the simple ones. Let's talk about parallel lines. What are parallel lines? You've probably seen pictures of parallel lines before, and they look something like this. Okay? Here I have two parallel lines. And in essence, parallel lines are just straight lines that never touch and go in the same direction forever and ever. So we have two straight lines that never touch and go in the same direction forever and ever. Now you may notice a couple of things about these lines. One, there's only one letter for each line. That's because we're not really interested in identifying points on the line. Right now we just want to say, listen, I want you to look at this line here. We're just going to call it I for now, and this line here we're going to call it J for now. So this would be my line I, this would be my line J. And then you notice these two double red arrows here. Those two double red arrows are indicating that my lines are in fact parallel, that they are both going in the same direction forever and ever, and that they never touch. So if you want to show that two lines are parallel in your own pictures, you got to make sure to put those two double red arrows. Now, there is a special way to say that lines are parallel. If you wanted to say that these lines are parallel and you wanted to write that down, you would use a special notation. And that special notation, whoops, I don't know why that's moving. That special notation would look like this. It would say that line I is parallel to J. This is how I say that from the picture that line I is parallel to line J. I put the I put a parallel sign between it, and then the letter J. Next, let's talk about intersecting lines. Okay, intersecting lines. A picture of intersecting lines would look like this, and you're going to notice there's nothing special about it, it's not like anything you've ever seen before. And basically, intersecting lines are lines that touch at exactly one point. That's all they are. They're just lines that touch at exactly one point. So let's say, for example, then, that these are the same lines from above, except now they're intersecting. So I'm going to name this line I, and I'm going to name this line here J, and they're going to intersect here at this point E. Okay? There's no special notation in order to write that, but I just want you to notice that they intersect at one point, and that point where they intersect is point E. Next, we're going to talk about perpendicular lines, and I'm sure you guys have heard about those before. Perpendicular lines. Well, first, let me give you the definition first. Perpendicular lines are lines that touch at one point and make 90-degree angles at the point where they touch. Perpendicular lines touch at one point and make 90-degree angles at the point where they touch. So let me show you a picture of some perpendicular lines here. Okay, here I have line K. Move this down a little bit. Here I have line K. Here I have line L. They touch at one point here, which doesn't happen to be named. We can name that point E if you like, right? They touch at one point and they make 90-degree angles. You see this little red mark here? Whenever you see that little red mark, that means that you have a 90-degree angle, also known as a right angle. Also known as a right angle. Special notation for writing perpendicular lines is this little upside down T here. Here I'm saying that K is perpendicular to L. That's how I write it. K is perpendicular to L. Now, something interesting that you should know about perpendicular lines, if you look at these first perpendicular lines here, you could say that they're on the same plane. If the screen is the plane that goes on forever and ever, we can say that line K and L are coplanar because they are on the same plane. But do perpendicular lines always have to be coplanar? And the answer to that, ladies and gentlemen, is no. If you look at this picture here, I have a line coming down here through the plane. I have another line going on the plane there. Let's name those lines now. Let's say that this is line J, and let's say here that this is line K, and that they intersect at this point here at point E. Well, line K and line J are in fact perpendicular. They make 90 degrees. So perpendicular lines can be coplanar, but do they always have to be coplanar? The answer is no. Here line K is on the plane. Here line J is going through the plane. So they don't always have to be coplanar. Okay, that's enough about lines. Let's start talking about angles now. Let's talk about types of angles. Let's take some notes on types of angles. Okay, the first type of angle that is probably the easiest to remember is a straight angle. A straight angle. And a straight angle looks something like this. It's just a straight line. Usually you'll have points denoted on it because you know that every angle, if you remember, an angle is made from two rays that share a common endpoint called a vertex. So here's my straight line. Let's name this point A. Let's name this, let me make that a little bit bigger. Let's name this point A. Let's name this point B. Let's name this point C. Real quick question. Is B a midpoint right now? Is B a midpoint? If you answered no, you are correct. B is not a midpoint because we don't have any congruency marks indicating that that segment AC is being bisected into two equal parts. But anyway, let's not get away from what we're talking about here. We're talking about straight angles. Well, here I have a straight angle. And if you notice, if I measure from this end all the way to the other end, it goes from 0 degrees to 180 degrees. And if I start on this end, it goes from 0 degrees all the way to 180 degrees. So a straight angle is basically an angle that measures 180 degrees. It's an angle that measures 180 degrees. Okay? Next, let's talk about an angle that you're probably very familiar with already. And those angles are right angles. Let's talk about right angles. Right angles are angles that measure 90 degrees. These examples here are examples of right angles. Notice I have an angle here. I have a 90 in the middle. You know that angle rate, 90 at the vertex, I should say. You have this angle measures 90 degrees. It's a right angle. Here I have the little red box, which is indicative of 90 degrees. So it's a right angle. Here I have two perpendicular lines. How do I know they're perpendicular? Because I have two lines that are intersecting and they are creating a 90-degree angle. That's how I know that they are perpendicular. Next, let's talk about acute angles. Let's talk about acute angles. Acute angles are angles that measure less than 90 degrees. So look at here, look at this vertex here. Notice they're not named right now. We're just focusing more on the measurement. Notice this angle here between the two rays is 33 degrees. This one is 56. This one is 89, almost 90, but no, not quite. So anything that's less than 90 degrees is an acute angle. I had one of my students tell me that a cute girl weighs less than 90 pounds. So that's one way that he remembered. I said, hey, whatever works for you. If a cute girl weighs less than 90 pounds, then that's an acute an angle. Next, we have obtuse angles. Obtuse angles. Okay, here are some pictures of obtuse angles. And obtuse angles, if you don't know, are angles that measure more than 90 degrees. There are angles that measure more than 90 degrees. So as we look here, whoops, didn't mean to go that far up. All these angles, 101, 91, ooh, almost 90, but it's more than 90. 129, these are all obtuse angles. And you might be familiar with those. Now let's talk about some that you may not be familiar with. The first one we're going to talk about is complementary angles. Complementary angles. And the definition of complementary angles are angles that add up to 90 degrees. There are angles that add up to 90 degrees. So if we look here, we have angle 1 and angle 2, and if I add them together, they equal 90 degrees. Notice that the angles don't have to be together. They don't have to be adjacent. They're just two angles that add up to 90 degrees. So here it says pairs of complementary angles, angle 1 and angle 2. Well, these two angles, since they add up to 90, they're what? They are 90 degrees. Over here, the angles 3 and 4, they are adjacent. The angles are adjacent. They're next to each other. They're sharing a vertex and a side. And since they both add up to 90 degrees, they're also complementary angles. So complementary angles can be separate. They can be adjacent. As long as they add up to 90, they are complementary. Next, we have supplementary angles. Next, we have supplementary angles. Let's move this up a little bit here. And supplementary angles are angles whose sum is 180 degrees. They are angles that measure up to, that add up to 180 degrees. So here I have angle 1 and angle 2. If they add up to 180 degrees, then angle 1 and angle 2 are supplementary. Again, you have two separate angles here, angle 3 and angle 4. If they also measure up to 180, then they are both also supplementary. They are supplementary. Here I have pair of supplementary angles, 1 and 2, and 3 and 4. Now there's something interesting I'd like to point out right away right now. Do me a favor, look at this first example here. Look at this first example here. Isn't this a straight line right here? Is it a straight line? And we know that a straight line, that if I went from here to here, it would measure 180 degrees because that's a straight angle. What if I went the other way? What if I went the other way? What if I went this way? What if I went this way? What if I went from here to here and then all the way across here? Wouldn't that be also 180 degrees? That would be 180 degrees. Yes, it would. So from here to here, this little angle here being added with the rest of that angle there, that would be 180 degrees. That's why angle 1 and angle 2 are supplementary. Now, one way that you can remember it is if you have a little bit of trouble, notice that the that the number 90 is smaller than the number 180. Well, notice that the letter C, if you think of it, is actually a smaller letter than the letter S because it comes first in the alphabet. So 90 goes with the smaller letter, 180 goes with the bigger letter, S, later on in the alphabet. Okay. Next, now here's where it gets a little bit deep. It's going to get a little deep now, guys. Now we're going to talk about vertical angles. Vertical angles. Vertical angles. And before we talk about the description, I want you to notice something here. Let's take a look here. These are two intersecting lines. These are two straight lines that are intersecting at a point. And it's saying here that angle 1 and angle 2 are vertical. Here I have two perpendicular lines. I know they're perpendicular because they're creating a right angle. They're making 90 degrees. And they're saying that 3 and 4 are vertical angles. Here I have two intersecting lines, and they're saying that angle AED and angle BEC are vertical angles. Well, let me point that out a little bit clearer. Let's take a look here and see if you guys can tell me what the definition of a vertical angle is. Here's angle 1, and here's angle 2, and angle 1 is measuring the space between these two rays here, between this ray and this ray. And angle 2 is measuring the distance from this ray to this ray, and these two are vertical angles. Look at 3 and 4. Angle 3 is measuring the distance from this ray to this ray, and angle 4 is measuring from this ray the distance from that ray to that ray, and these two are vertical angles. What is your definition of a vertical angle? Let's take a look here at this. Let's take a look at angle AED. AED, okay, that's this angle here. Let's take a look at angle BEC. Here's BEC. Okay, well, looking from this picture then, this first angle is measuring from here to here, and the second angle is measuring from there to there. Okay, notice a pattern here when they're making reference to vertical angles. Let's take a look at the other pictures. At the other angles. Let's take a look at angle AEC. Well, here's AEC right here, and then here is DEB. DEB. So when I'm making reference to those vertical angles, I'm talking about the distance from this ray to this ray, and from this ray to this ray. Okay? Notice that in here, for these vertical angles, my intersecting lines are straight, perpendicular lines are straight, intersecting lines are straight. Okay? Over here though, wait a minute. 1 and 2, these are what? Not pairs of vertical angles. So 1 and 2 are not vertical. 3 and 4 are not vertical. Okay? Here you might say that, oh, wait a minute, see, this looks a little bit similar to this one, first one here. But when you look at the lines, are the lines straight? No, the lines are crooked. The lines are actually a little bit crooked. So that kind of contributes to our definition of a vertical angle. Because if my line was straight, if our lines were straight, and they would go straight like this, right? They would just keep going. They'd keep going right here. They'd be straight that way, but no, but instead it kind of bends to the right. Okay? So yeah, so wait a minute. So, how about 7 and 8? Yeah, this is a straight line, but this one is straight and it stops. This one is straight and it stops, but these are not vertical angles. And these are not vertical angles. So take a minute and take a second to think about what is your definition of a vertical angle. And we're going to discuss that right now. Next, let's move on to a linear pair. Let's talk about linear pairs. Okay? Let's talk about linear pairs. Well, here we have some pictures of linear pairs, and here we have some pictures of nonlinear pairs. Well, let's look at the ones with the numbers first. Here they tell me that angle 1 and angle 2 are linear pairs. Let me scroll up a little bit. Linear pairs. So here I have angle 1 and angle 2 are linear pairs. Well, here's angle 1 measuring from this ray to this ray. And here is angle 2 measuring from that ray to that ray. And these two are a linear pair. What does that mean exactly? Well, let's take a look at angles 3 and 4. They say 3 and 4 are also a linear pair. Well, angle 4 is measuring the distance from this ray to that ray. And angle 3 is measuring the distance from this ray to that ray. Are we starting to figure out what a linear pair is? How about AED? Well, here's AED. Here's angle AED right here. Right? AED is measuring the distance basically from this ray to this ray. And then I have angle AEC. 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 Okay? So we're measuring the distance from this ray to this ray. Okay, where's this? Okay, what's the linear? Let's look over here. What are not linear pairs? Well, notice something before we move on to that. Notice over here, intersecting lines are straight. This line is straight. Doesn't go all the way through, but it's straight. These are intersecting and they're all straight. What is our definition of linear pairs? Well, I'm going to give you a hint. Linear means line, pair means two. So my definition would probably be two angles that together create a straight line, or 180 degrees, right? Because if you notice, we go from here to here, we go through two angles, and we get a straight line. From here to here, we go through two angles, and we get a straight line. From here to here, we go through two angles, and we get a straight line. So, linear pairs make a straight line of 180 degrees. Together, the angles measure what? 180 degrees. Together, when I say together, I'm talking about the angles. And since they make 180 degrees, linear pairs are supplementary. They are supplementary. Okay? So, let's see if we can do a couple of practice problems and review them together.